Good morning. In this class, we're discussing about the one-dimensional problem under the topic of finite element modeling and the element divisions. So let's move on the topic. So here we are detailing about the one-dimensional problem. So how they can be FEA can be utilized for that kind of problems. So the finite element modeling of the element divisions, a visible guide. The finite element is nothing but is a conversion of the physical problem into the discrete numerical models. So for example, if you're taking the one-dimensional element, so we have to segregate the two elements. After that, only we have to construct the respective nodes and element we can to apply for the respective element. Then the geometry is defined as a using nodes and the elements and boundaries. And also, we have to define the material property of the assigned and the load boundary conditions also apply. So generally the governing equations of the solving the numerical problem, after that we have to getting the result of displacement and the strain and stress and temperature, etc. So as the empathy, what is the finite element method? As a concept, the finite element is a conception techniques using for the resolving complex engineering problem by breaking the large system into smaller, like a similar parts of the finite elements. So the applications are the widely using the structural analysis like a fluid dynamics, heat transfer, electromagnetic, and biomechanisms. So, what are the benefits of the this kind of FEA? The providing the detailed insights into the stress, strain, and temperature, and also the flow distribution of the optimization design and the prediction behavior. So, first of all, the step one is we have to consider the dividing the continuum. So, the initial stage in FEA, the involving the breakdown the complex geometry of the structure into the collection of the similar magnable shape and referred as the finite element. This process called as a discretization, the simplification problem allowing the easier mathematical analysis and numerical computations. The element type, we have to choosing the right building block. So for example, if you're taking the one-dimensional element, the beam and stress element is suitable for the slender component that carry the axial or bending mode. So while choosing the two-dimensional element, often the triangular or quadrilateral used for the thin structural or cross-section analysis. For example, say example of plate and slits. So if you're taking the three-dimensional element, that typically the tetrahedral and hexahedral for the solid structure with the complex geometry. So example, engine block and the missing part. So the nodal points and degree of the freedom. So the nodal point is nothing but they have to discreting the point where the finite element is connected. And they are the crucial for the transforming the information and maintain the continuity across the discrete model. So degree of freedom is nothing but the DOF is represent the fundamental movement of the characteristics of each node that also can be displacement of the translation and the rotation and the other physical quantities like a temperature and pressure. So the element meshing techniques is nothing but either we have to define as a automatic meshing or manual meshing. So by choosing the automatic meshing, the software driven the generation of the element and ideal for the complex geometries offer the speed and efficiency, but might be it can be defer the refinement. But in manual missing is nothing but the user define the element and create creations offering the precision control over the miss quality, often used for the critical area or specialized analysis. So the missing consideration, the one is quality, density, and the computational cost. So while going for the quality to ensure the accurate result and preventing numerical error. So for density, the finer mesh and providing the higher accuracy but increasing the computational timing and the computational cost, the numerical element and no directly impact the process and time. So overall, the summaries of the finite element modeling and the element divisions. So first of all, the FEA is a modeling is a process and also divided the element. So while going the process, the representation, define parameter and methodology. So after the methodology, we have to take the two cases, continuous discrete conversions and numerical computer solutions. So for the element divisions, structural, mesh density, and objective. So the mesh density we have further classified is a thinner meshes and coarser meshes. Thank you.